Now there are address binding. We'll talk about various address binding. First of all, address binding means whenever you have a program, there are instruction data and they bind themselves to certain memory address or memory part. So the collection of processes on the disk that are waiting to be brought into memory for execution, they are kept in the input queue. So processes, they normally reside, or they can reside in any part of the memory. If this is the main memory, it can reside in any part. So addresses in the source program, they are generally symbolic. What I mean when we say that the address in your source program, like the factorial or the Fibonacci series program, you say the addresses in the source program, they are generally symbolic. Why? Because the compiler binds these. Compiler is what? Compiler is the program which converts your program or your basic program into the code which is understood by the computer. That is the machine code. So compiler does what? Compiler has various aspects. We'll see about that. So compiler binds these symbolic address, which are the addresses of the source program, to the relocatable address. And what are these relocatable address? I'll show you just now. The linkage, after this we have linkage and loader. This binds this relocatable addresses to the absolute address. Before going to that, let us see first of all what is the address binding. First of all, address binding of your program's instruction data to certain memory addresses can happen in 3 different stages. Means these are the stages. First of all, you have compile time, then you have load time, and you have execution time. So what I'm trying to say is, whenever you are dealing with or you are talking about address binding of your program instruction data, this can happen at 3 different stages. First is compile time. That is, if the memory location is known previously, absolute code can be generated. But if you recompile, it has to start from the initial. The recompilation has to be done if the starting location changes. How about load time? Here, it must generate relocatable code if the memory location is not known at compile time. You will be understanding this with the diagram. Execution time is, the binding is now delayed until runtime. If the process can be, now the process can be moved easily from one part of the memory segment to another part. This you can do. So it needs some certain hardware support. That is, you ought to have some base and limit registers. So these are the steps which I was talking about. You have a source program. As I just said, you can have any source program. Now the compiler and assembler does what? It will give you an object module. So this place where this binding is there, this is called compile time binding. Now when the object module is there, there can be other object modules which linkage editor can link, and then it will give it to the load module. And then load module can take some other like system libraries like stdio.h or conio.h. All this will be combined, and this loader will take all these. And this is the load time binding. So this is the binding going on. And then after that, the actual exe or the binary memory image will be made. This is the dynamic. You can have some dynamic linking. At this time, the binding is execution time or runtime binding.